Did you know that the most powerful explosion in the universe is gamma ray burst? One of the greatest mysteries of all is what causes gamma ray burst. According to NASA, these bursts are the most powerful explosions in the universe and occur about once a day. Their origin is unknown, although there are several theories. Though they last seconds, gamma ray bursts produce as much energy as the sun will emit during its entire 10 billion years existence. According to research, there are two types of gamma ray bursts, long GRBs and short GRBs. Long GRBs last about a minute and scientists think they are produced by supernova, while short GRBs last a second and are produced when two neutron stars in a binary merge. Both could cause a massive extinction if it reaches the Earth. But a nearby GRB could already be disastrous. If one goes off within a few light years from us, it would totally burn the surface of the Earth or at least the half the sea. But as said, even a more distant GRB could still end life on Earth. It's been suggested that because of GRBs, only 10% of all galaxies might be hospitable to life similar to us. Luckily, it's unlikely for a GRB to hit a galaxy like ours, and to harm us, they must be caused and directed at us. But since gamma rays travel at the speed of light, we won't know when it's headed our way until it arrives. So there could already be a GRB on its way to kill us all, and we won't know it until it arrives. Fortunately, all the bursts we have detected so far originated outside the Milky Way, too far away to hurt us. Have you learned something amazing from this episode? I hope so. So that ends our episode for this day. This is Maria Jana Castro, thanking everyone for coming with me as I unveil the unknown of science. Thank you for watching.
Alam niyo ba na ang lift, weight, thrust, and drag are the four forces that keep an airplane in the air? Lift is the force that pushes the airplane upward as the air moves around the wings, and weight is the force that pulls the airplane toward it. The weight of the airplane is also distributed from front to back, which maintains the airplane's balance. Thrust is the force that propels the airplane forward, whereas drag is the force that slows it down. Airplanes are designed to allow air to pass around them with as little drag as possible. At alam niyo rin ba na ang naka-invento nito ay magkapatid at yun ay ang Wright brothers.
So, hello everyone, I'm Lansky and Sam Kabikting, and I'm here to give you some facts about physics that you're probably not aware of. You may be familiar with physics and its background, and you want to know more about its different concepts. So, here's the question. Alam mo ba? Alam mo ba? You may know a lot about Isaac Newton and its discoveries. Pero, alam mo ba? Isaac Newton is the first physicist. He is popularly remembered as a man who saw an apple fall from the tree and was inspired to invent the theory of gravity. Alam mo rin ba na si Marie Curie was the first woman with a Nobel Prize in physics. She is considered up to this day to be the mother of modern physics. Amazing, isn't it? Alam niyo ba, the astronauts who are in the International Space Station experience the time slowly since both velocity and gravity have an effect on the speed of time. This is why astronauts kind of look younger to us. Daily life aboard International Space Station moves fast, like really fast, traveling at approximately 70,000 miles per hour and 300 miles above the Earth. Astronauts watch shining sunrises and sunsets every day while floating around in a box with a handful of people they depend for survival. Alam mo ba, There are physical changes or effects after coming back to Earth from space. Scott Kelly was a US astronaut who experienced effects after coming back to Earth. He spent 11 months aboard, so he said that there are physical changes where there's stiffness, swelling of his legs, rashes where his skin hasn't touched anything. When he was in space, you lose significant amount of blood cells or blood volume, so you need to regain it when you get back very quickly. But when you didn't regain it, the red blood cells you lost with it, and it takes months to recover. That makes you feel fatigued. So it takes 6 to 8 months recovery. So without the proper diet and exercise routine, astronauts also lose muscle mass in microgravity faster. Alam mo ba, the longest of any one person has spent in space is a Russian former cosmonaut Valery Polyakov, is the holder of the record of the longest single stay in space, staying aboard in the Mir space station for more than 14 months, which is 437 days and 18 hours during one trip. Amazing, isn't it?
Good day! Alam niyo ba na ang bisikleta ay kayang ibalanse ang sarili o kaya tumayo na mag-isa kahit na walang tao dito sa pamamagitan ng gyroscopic effect. At first thought, you may think that the human rider is what gives a bicycle balance. This ends up not completely true. If balanced properly, a modern bike with no rider balances itself is fine and continues on its path as if a rider were guiding it. This can be easily verified by anyone with a bike and can make for amusing scenarios such as in this video. Up until a few decades ago, scientists thought that a bicycle is self-balancing when in motion because of gyroscopic effect. Gyroscopic effect means that the spinning wheel tends to stay aligned in its original direction. This effect is used mechanical navigation gyroscopes to maintain a proper sense of direction as a vehicle travels about. The gyroscopic effect is a direct result of the conservation of angular momentum or spinning motion. In the absence of an external force, the total angular momentum of a system must retain the same strength and orientation. As a result, a small force does little to make a fast spinning heavy wheel tilt away from its original orientation. Some physicists thought that the spinning wheels of a bicycle create enough angular momentum to resist the tilting that occurs when a bike falls. Bike designers understood the full physics of bicycles. They have to in order to properly design and optimize bikes. But a hard time distilling down the huge equations into simple, understandable concepts such as gyroscopic effect. Experiments in the last few decades have made more sense of the underlying equation and demonstrates that even if the angular momentum of the wheels is cancelled out, the bike is still self-balancing. The angular momentum of the wheels can be cancelled out by adding two or more that spin in the opposite direction as the original wheels and are configured to no touch the ground.